Okay, today we're going to be talking about section 7.1, exponential functions. And to be honest, exponential functions are the things that we use the most mathematically in the real world. And it's because it's talking about money. We love to see how our money is going to grow. We also love to look at our lovely little world and see if our population is growing or if our population is slowly dying off in certain countries, and what could be the cause or the effect for those things that are happening within those countries. So population growth and decay, as well as how our money is growing, is what we use exponentials for the most. Right here, y is equal a to the bx is going to be any of the forms that we're going to be using for exponential. A cannot be 0, and a is what we're going to call our initial amount, and b is going to be what we call our exponential growth or decay factor. Okay? Now, we are going to have an exponential growth model when x increases and your y value decreases. So that means as you grow, as x gets bigger, your y values get bigger as well. So whenever we invest $1,000, we like to see that $1,000 grow very quickly and have a very quick upswing. Does that make sense? Then we have what we call our decay factor. Decay factor is going to be when x increases, your y value decreases. So what you will see here is we're talking about people living much longer than compared to the 1920s or the 1940s. So we would have had a very slow decay rate, meaning the more that people get older, the longer it takes for them to die. Our decay rate is dropping. Okay? Does everybody understand that? Okay? An asymptote is going to be a line of the graph that it approaches, but it never crosses. In this case, we're talking about this right here. Okay? It gets really, really, really close to the x-axis, but it is never crossing the x-axis. Okay? Now, with that being said, the biggest thing your mind needs to understand is that your a value is always going to be positive. Okay? Your a value is always going to be positive. So when a is greater than 0, you're going to have either growth or decay based upon your b value. If your b value is greater than 1, you're going to have growth. If your b value is between 0 and 1, meaning a fraction, you have decay. It's that simple. Okay? Now, your y value, or your y-intercept, is going to be 0a. It's the initial amount that you start with, the amount of money that you invested, the amount of the population was at that given time. It is the initial measurement value. You with me? That is your y-intercept. Then, your y-asymptote is going to be y equals 0, meaning it's going to be the value that it cannot cross. It's that asymptote line. Not very concerned about asymptotes today. You're not going to hear me talk about those a lot. We're going to talk about real-world problems more today than anything. Okay, now, the growth model is when b is greater than 1, and this is called the growth factor. Then, we're going to have our decay model, and that is going to be when b is between 0 and 1, and that's a decay factor. Example. Okay? Example. Identify each function or situation as an example of an exponential growth or decay. These are just like problems 1 through 4 on tonight's homework. So the very first thing your brain wants to highlight is your a value. Your a value is greater than 1. What is happening to this thing? This thing is going to be growing, and what is happening to our y-intercept is going to be the point 0.12. Now, 0.95, is that between 0 and 1, or is that greater than 1? Is that between 0 and 1, or is that greater than 1? It is between. So therefore, that means this is going to be a decay. Do we all understand that? That's going to be a decay, and the decay is going to be 0.95. That's how much it is decaying. The next one, what is going to be my y-intercept? My y-intercept is this right here. That right there is going to be the 0.25 is my y-intercept, and then I'm going to have my b value. Your b value is going to be right here. Is that going to be greater than 1? Yes, it is. So therefore, that is going to be a growth. And my growth value is going to be 2. Okay? Okay, now we are going to think about this one right here. You put $1,000 into a college savings. What does that stand for? A or B? A, it's your initial amount. So A is going to be $1,000, which means your Y-intercept is going to be the ordered pair 0, 1,000. Does everybody understand that, yes or no? Then it says the account, and you're putting it in your savings, you're putting an account for 4 years. The account pays a 5% interest annually. Is my money going to grow or is it going to decay? It's going to grow, and I need your brain to understand that not only is it going to grow, but I want 100% of my money, and then I'm going to add to it how much every annually? 5%. So that means that I have 105%. I need to change my percent to a decimal. So what decimal will that be? Well, here's my decimal here, so I'm going to go over 2 units. So that's going to be 1.05. That is your growth. Does that make sense? 105% is the same thing as 1.05. Do we all understand that, yes or no? Yes? So we did not actually have to do anything with that, but just identify your Y-intercept and then also identify the exponential growth or decay factor. Any questions over this? This is problems like on your homework, 1 through 4, okay? Now, here is our lovely formula. Our lovely formula is going to say your balance in your account is going to be your initial amount plus your growth or decay of 1 plus R. R is your rate. And then T is going to be the time that you're going to have it in there. Okay? So that's what we're going to be utilizing. So let's look at this problem right here. You invested $1,000. So what is that going to be again? If I were to look at it in this formula, A of T is equal to A parenthesis 1 plus R raised to the T. Now, what is A in this problem? $1,000. At the end of the 6th grade year, the account pays 5% annual interest. Am I growing or am I decaying? I am growing. So my rate is going to be 5%, which means I'm going to have 100% plus 5% to give me 105%. Do we all understand that? Which means this whole number is 105. Do we get that? That whole number is 105. So I have A of T is going to be equal to my initial amount, which is 1,000, and then I'm going to have 1.05. Why is it 1.05? Because I'm changing the percentage to a decimal, and then I'm going to have up here your time, and it says how much money will be in your account after 6 years, so that's going to be a 6. Do we all understand that? So I'm going to come over here to our lovely little Desmos. And I am going to type this in. And I said that we have $1,000, parenthesis 1.05, close parenthesis, and then I'm going to raise that to the power of 6. And how much money will I have in my account after 6 years? Not 9. 10 cents. So we are going to round to the nearest cent. So in my account, I am going to have $1,340.10. That is how much money I will have in my account after investing at a 5% interest rate of $1,000 for 6 years. Do we all understand that, yes or no? Is that a good investment or a bad investment? 5% is a whole lot better than 2.5, which is what your standard bank gives you. So if you can get a 5%, you want to grab that, okay? This is not where you want to put thousands of dollars, though. You'd rather go into investing with a 7% or higher interest rate in the money market or into just regular stocks and bonds and things like that, okay? So this is tonight's homework. We're going to start that here in a second.